All right. Well, my name is Jordan Swain Fox. I'm the outreach coordinator for the Center for Urban and Regional Analysis, or CURA, at The Ohio State University. And we're pleased to welcome you today to our second webinar in our Maps from the Past, the Impact of Historical Urban Maps on the Past and Present series. This is a series co-sponsored by CURA and the University Library's Research Commons. And throughout the series, we're hearing from presenters engaged in research with historical maps to illuminate the links between urban challenges and impacts old and new. Today's guest, Jonathan Tollefson, will discuss how they've used Sanborn Fire Insurance maps to measure changes in the social stratification of environmental exposure in American cities from 1880 to 1930. Before we introduce Jonathan, I want to mention a few logistical items for the presentation today. If you require closed captioning, you'll find a box at the bottom of the screen labeled with CC. Click this box and select Show Subtitles to view subtitles during the presentation. Feel free to submit questions at any time using the Q&A box. You'll notice that the chat function is disabled, so please use this function if you have any information to share with the organizers or if you have questions for the presenter, and we'll get to those at the end of the session today. As you may have seen on our website, this event is approved for 1 AICP CM credit. And to claim your CM credits, you can log into your My APA account on the APA website and enter the event into your online CM event log. At the end of the webinar, there'll be a brief survey that pops up. If you have time, we encourage you to provide your feedback to help us improve these events. And if you have any questions following the event, don't hesitate to email us at cura@osu.edu. To learn more about CURA's future events or to sign up for our monthly newsletter, visit our website at cura.osu.edu. And you can also like CURA on Facebook and follow us on X, Instagram, and LinkedIn. You can learn more about the Research Commons at their website at library.osu.edu/researchcommons. And with that, I'll pass it over to the Research Commons Geospatial Information Librarian, Josh Sadvari, to introduce our speaker for the day.
Thanks, Jordan. Hi, everyone. My name is Josh Sadvari. I'm the Geospatial Information Librarian here at Ohio State. I'm really excited to introduce today's speaker, and I'll also be moderating the Q&A at the end of the presentation. So as Jordan mentioned, please add your questions there throughout, and we'll get to as many as we are able. Today's speaker, Jonathan Tollefson, is a PhD candidate at the Brown University Department of Sociology and the Institute at Brown for Environment and Society. Their research investigates inequality and stratification as environmental processes, with a focus on long-term trajectories of social and environmental change in cities. Jonathan's work is supported by a fellowship with NIST's Professional Research Experience Program, and I'll go ahead and turn it over to you, Jonathan.
Great. Thanks, Josh, for the introduction. Yeah, it's a real honor to get to speak to you all today. Really looking forward to the rest of the series this summer. Helen's talk in a couple of weeks and the rest of them as well. And I'll jump right into it. So the central, as Josh mentioned, the central part of my research is about understanding the environmental dimensions of these core questions of urban inequality. And in particularly in how society-environment interactions shape the formation of social stratification and inequality over the long term. And what I'll be talking about today is kind of the main project that comes out of this broader research agenda. So my main goal in the talk is going to be to address a historical and methodological and theoretical gap in the environmental and urban sociology literatures in order to understand how environmental risk is embedded within broader patterns of inequality in cities, and specifically to understand the role of environmental hazards in the formation of the segregated and unequal neighborhood. And then historic maps and computational methods to read them are going to be kind of the key to unlock these processes that tied environmental risk and urban inequality together starting in the 19th century. I'm asking a few key questions here. These are, how did environmental inequality shift during the formation and solidification of neighborhood segregation? What was the role of race and ethnicity in the stratification and environmental exposure during this initial period? And what does this reveal about the nature of urban inequality and urban change more broadly. So my contention here is that sociological theories of the formation of urban inequality are missing an environmental perspective. And so the beginnings of a sociology of urban space really emerged in the 1980s, alongside pressure from environmental justice movements to address this problem of racial and socioeconomic disparities in exposure. Since then, we have ample evidence that environmental risk is strongly associated with racial and economic marginalization. But even as that research expanded over the last 40 years, the historical bounds of most of that work really remain left-censored to about the 1980s. And this is because the research program that emerged out of that period really relied on EPA and other regulatory data. And because pre-EPA data are really hard to come by for a number of different reasons to talk about in more detail. These earlier periods really remain a black box for urban environmental research. And as a result of this, theories of environmental inequality are based on a case universe in which neighborhood scale racial segregation was already an established fact on the ground. And to get at that, I'll talk for a moment about the spatial history of segregation in US cities. So racial segregation at the neighborhood level is relatively recent. If we go back to the late 1800s, city residents lived, of course, in deeply segregated, unequal spaces, but this was generally organized on a street-by-street and household-by-household basis. And it really took until the 1930s and 1940s for segregation to scale up to that neighborhood level. Neighborhood scale segregation peaked alongside the rise of the environmental justice paradigm in the 1970s and 1980s, and remains, of course, a really key structure shaping urban inequality today. But it really wasn't until that form of spatial inequality had solidified into what Massey and Denton had called this near-apartheid structure that sociologists started to turn their attention to urban environments in a sustained way. This means it's not yet clear the extent to which theories of environmental inequality formation reflect the assumptions that are embedded in that limited temporal focus. So we know that racial inequality shapes environmental marginalization, but because this literature is largely limited to the EPA-era, we risk treating environmental processes as an outcome of these kind of underlying socio-spatial patterns, rather than as a potential cause. This means that urban environments are really siloed from the dominant explanations for the rise of neighborhood differentiation. And that contributes to what Kevin Loughran's called urban sociology as limited collective advance toward a deep and sustained environmental consciousness. And we've really been unable to deal with this kind of presentist theoretical problem because we don't have the data to do so. I'm glossing over a lot, there's been a bunch of literature pretty recently that's starting to open up the post-World War II deindustrialization period to analysis. And that's a wonderful conversation. I'd love to talk about it in more detail. But the sort of late 19th and early 20th centuries when racial segregation was getting established at the neighborhood level really remained under-researched and under-theorized. And so my work is aiming to close that theoretical gap. And to do this, I'm going to take advantage of a historic map documents to geolocate a particularly important source of environmental risk in this earlier period to open it up for analysis. I'll go into what that kind of case selection for a moment.
Jonathan, sorry to interrupt. We're hearing that your audio is cutting out a little bit. If you're able to maybe stay a little closer to the mic.
Thanks. Sorry, I have a computer that's good at statistics and not very good at other things. So hopefully if I get up here, it'll be a little bit clearer. So yeah, please interrupt me again if I'm not totally audible. Yeah, so up on screen here is a Gasworks Park in Seattle, Washington. And starting in about 1906, the site was home to a gasworks that was run by the Seattle Gas Light Company. There are only a few kind of remnants of that site left today, but in the early 1900s, it took up the whole of that peninsula that juts out into Lake Union. And it was really the primary source of fossil fuel energy for the city. Coal was brought in on trains and barges, and it was heated to about 400 degrees Celsius in these enormous retort ovens, passed through a number of chemical processes. And then it was stored on site in these enormous gas holders, which are up there in the center of that left-hand image. Gas was distributed along a pipeline network to residents and businesses and industrial manufacturers, and it was used to light homes and cook meals and power machines. So Gasworks Park is unique in how it's preserved some of that history, but the gasworks that operated there was pretty standard. And that really started in the early 1800s. The industrializing cities all over the US started to rely on gas that was manufactured from coal for all these different uses. It was really the first urban fossil fuel utility, and it was a really massive industry. And the Seattle Gasworks was actually one of the smaller gasworks on record. Others were spanned multiple city blocks, or other ones still were a lot smaller, like this gasworks up on the screen, which served a textile mill in Providence, Rhode Island. So these gas sites really spread all across early industrial cities, and they're often interspersed among dense residential blocks. And that was a problem because the gas industry was, of course, a major source of environmental pollution. U.S. gasworks likely produced upwards of about 11 billion gallons of toxic waste over the industry's lifetime. And much of that was buried on site or dumped into local waterways. And that waste is incredibly harmful. Gas production saw almost no environmental regulation, but we do have a bunch of evidence that its products and its byproducts were widely understood to be harmful to human and environmental health. And those pollutants also stick around, right? So it's a major challenge for remediation today. The first Superfund site was actually a former gasworks in Pennsylvania. As natural gas started to take over in the 1930s, manufactured gasworks were converted or demolished. And this means that even though it was so extensive and so long-lived, the industry is still poorly documented. Some sites are listed in state or federal databases, but that's still incomplete. So it's a great case to understand late 19th and early 20th century environmental inequality formation for all these different reasons. But the next problem is how to build out a complete picture of that industry over time. So to do this, I developed a computational methodology to recover manufactured gas sites from historic building level map images. And I'm going to spend a minute or two on this because it's kind of the key methodological piece of the study, and it's the part that intersects with the historic map focus of the seminar series as well. Right, so manufactured gas is a useful case for all of these social reasons, but it's also useful because its architecture is distinctive in a way that makes it possible to identify in historic maps. And what I'm talking about here are these gas holder structures, these structures that are really emblematic of the industry across its lifetime. They are really clear in these detailed parcel level maps from this period. They were recorded as these labeled circular features that are up on the screen here. That's a pretty small gas holder in San Francisco. They ranged in size. A lot of them are much bigger. And maps like that are widely available starting in the 1880s. They were published by the Sanborn Fire Insurance Company, which mapped out about 12,000 cities and towns across the US at this extraordinary level of detail. They publish new city atlases about once every 10 years. So we have this incredible wealth of information about urban built environments over time that aligns with this key period in the reorganization of urban inequality that I'm interested in. But that level of detail is also their biggest challenge, right? So a single atlas of one city might add up to hundreds or thousands of pages. So over time, we end up with this data source that's unwieldy exactly because it's so rich. So we need a way to extract site data from this mountain of documents. And because they're so standardized over time, Sanborn maps lend themselves really well to computational approaches. So my approach to locating this particular industry in Sanborn map documents starts by using feature recognition tools to extract image segments that roughly match the circular features indicating manufactured gas storage tanks. In doing this, I'm treating every city block as a potential host for this kind of site and collecting every map feature that might be a potential match. But most of the candidate features, of course, are things that we don't care about. They're fountains or cul-de-sacs or their map lettering, other things. And to deal with that, I built out a machine learning classifier to sort out the manufactured gas sites that we care about from all these other candidate features. This involved coding a huge number of these candidate features to build out a training data set using these data to train an ensemble classifier, which consists of a combination of convolutional neural networks and multi-layer perceptron models. And what this gives us is what this gives me is a labeled output of every map document that contains this kind of infrastructure, making it possible to build out a complete picture of the industry within a given city across space and over time. Using Washington State as a test case, my approach actually ends up outperforming kind of these attempts by the EPA in the 1980s to locate sites by hand. And there's a couple of reasons for that I can talk about in more detail if anyone's interested. But also based on a case study of the Providence, Rhode Island area, the approach ends up identifying sites that are absent from state. So kind of this inductive approach to treating every city block as a potential host for this kind of infrastructure ends up doing a really good job of mapping the kind of gasworks universe across time. Oh, thank you. So I'll go ahead and outline how I use these site data to understand environmental racial inequality during these key decades of urban transformation. And to do this, I'm going to enrich census microdata with measures of residential proximity to active gasworks. And there are a couple special considerations for the period that I'm working in. The first problem is modeling exposure using measures that are appropriate to the spatial scale of 19th century cities. I'll mostly rely on census enumeration districts here. These were a lot like census tracts, but they were a lot smaller. So San Francisco, for instance, has about 190 populated census tracts today, but had almost 400 enumeration districts in 1930. I'm defining this level of residential proximity using an aerial approach, to select enumeration districts that were within close proximity to active gasworks. So then, individuals are considered exposed if they occupy a district that's within a short radius of one or more of this kind of infrastructure. And this is possible because enumeration district maps were digitized by spatial structures for the social sciences at Brown, which is a great resource for historical spatial data. So this gives me a relatively small scale measure of residential exposure to a particularly important kind of environmental pollution. But as a sensitivity check, I validate this approach with a smaller measure that's based on individual street segments. So this is following an approach that John Logan's team put out pretty recently that defines street segments as contiguously named streets that are bounded within a single enumeration district. So I can place individuals within these street segments using their enumeration district location alongside street addresses. And this lets me identify individuals who lived on the same street as an active gasworks in a particular year. We don't have access to spatial data below that enumeration district level. We don't have street grids that are mapped out or address locators for this period. So this lets me measure proximity at a smaller spatial scale than those available spatial data allow. In order to understand how environmental racial inequality changed over time, I'm setting up my analysis as a comparison between the 1880 and 1930 census year specifically. And that's for a couple of reasons. Substantively, that 1880 to 1930 period aligns with that reorganization of urban inequality that I'm interested in, and is also well timed to the peak of the gas industry as well, kind of right before it starts to be replaced by natural gas. And there's also a methodological reason. So 1930 is one of two census ways where enumeration district maps are widely available. And then my decision to compare that with 1880 is driven by the need to compare equivalent units over time. And I'm doing this by taking advantage of some unique data that are available for the 1880 census. These 1880 census data are unique in that they're available as geolocated points, so that I can reassign individuals in 1880 to 1930 equivalent enumeration district boundaries. So this way I can set up two waves for analysis that have an equivalent set of districts and an equivalent set of street segment units. So my approach then relies on a series of individual level logistic models that use a set of these sociodemographic variables, right, to predict residential proximity to coal gas infrastructure at both of these spatial scales. I'm using occupations as a proxy for class structure and a set of kind of standard sociodemographic control variables. And I'm computing race and ethnicity as a comparison between three mutually exclusive categories. Native-born non-Hispanic whites, who are the reference category, foreign-born non-Hispanic whites, so white immigrants mostly from Europe, and non-white residents as well. So this lets me kind of emphasize, right, the role of whiteness to insulate individuals from living near industrial hazards, and also emphasize the role of white privilege in the production of environmental inequality, which is informed by some, Laura Polito's kind of foundational work in that area. Also, nativity is an important part of labor structures in the late 19th and early 20th century, so that's why I'm kind of integrating that in this analysis as well. In order to directly compare model coefficients over time, I'm going to pool the 1880 and 1930 census waves and use an indicator variable to distinguish between those two census years. So we have this set of fully interactive models that make it possible to compare over time. And I'm investigating a number of different cases, and I'm going to model them all separately. So we can't, I won't be able to directly compare across cases, but this is because I'm interested in kind of the endogenous changes that were occurring within cities, and the more kind of abstract similarities that emerge in how these endogenous changes were structured. So that's sort of the model setup, and I'll spend a moment on case selection before moving on to the results. So my case selection process relies on being able to harmonize all these different historical data sources that I've introduced. And so the case universe is initially limited to the 28 cities that have georeferenced census data in 1880 and enumeration district maps for the 1930s. And within that, I'm working within the publication timeline for the Sanborn Map Company. Because of that, kind of taking advantage of that special 1880 data, I need to focus on cities that have Sanborn data available in 1880s as well, which is a relatively limited, that's kind of right at the beginning of their publication timeline. So that limits the case universe pretty significantly as well. And then also because I'm relying on digitized Sanborn data from the Library of Congress, I'm kind of beholden to their progress in digitizing Sanborn atlases. So intersecting these criteria gives 11 different cities that have the right data at the right time, and I'm selecting 6 cases out of those to maximize regional variation and give me a wide range of sociodemographic histories. There's actually 7 cases, but I'm combining the San Francisco and Oakland areas because they're kind of an integrated regional economy. So those cases are the Baltimore, Cleveland, and Minneapolis, New Orleans, Providence, and then Oakland and San Francisco cases. They represent some of the most significant industrial cities in their respective regions that satisfy these data availability criteria. The cases provide some useful demographic variability. So Minneapolis and Providence were primarily white cities across this 50-year period. Baltimore and New Orleans were both home to really significant Black communities over time. And then Oakland and San Francisco had smaller Black populations, but significant Asian communities across this period as well. Cleveland is interesting. It was a mostly white city in 1880, but had a growing Black population by 1930, mostly as a result of the Great Migration. All the cases saw massive population growth as the U.S. transitioned from a mostly rural to a mostly urban country. And of course, neighborhood racial segregation was solidifying rapidly in each of these cases as well over this period. Yeah, I'll move on to the results of this site identification process to begin with, and then talk about the analysis of the stratification of environmental risk over time. So the 7 cities amount to about 27,000 Sanborn map pages in total, and applying this site identification methodology reveals 60 gasworks sites across the 7 cities. And I'll zoom into San Francisco to give us an idea of what this looks like. So here's the landscape of gasworks in San Francisco in 1880 and in 1930, split between sites that were in active use and relic sites that were decommissioned or demolished by the time that I'm mapping them. I'm focusing on active sites right for the analysis, but these kind of relic sites can give us an idea about how the industry is changing over time. San Francisco is pretty representative here. We start to see this gradual shift in energy production away from downtown towards the industrial periphery as throughout this 50-year period. And this is happening at the same time as this huge wave of urbanization and population growth. So industry and population are in motion. But what does this mean for the stratification of environmental risk? Right, who's living next to these major sources of environmental harm, and how does this change over time? And I'll present my results using the results of that analysis using focusing on the average marginal effects of the key variables that I'm interested in 1880 and in 1930. And because I'm interested in longitudinal changes, I'll further focus on the difference between these marginal effects at each of these points. So this kind of second difference statistic is going to tell me how stratification of environmental risk was changing over that 50-year period. So I'll start with the stratification of environmental risk in 1880 at the start of the study. So these are the effects of key race, nativity, and occupation variables in each of these 6 urban areas, right, combining San Francisco and Oakland into the San Francisco Bay Area. In dark gray on the left of the charts are the effects of the non-white and the foreign-born white variables, both compared to non-white or non-immigrant whites. And then in light gray are the occupation variables related to labor and professional and service occupations. And those are compared to individuals who are outside of the labor force. Because they're modeled separately, right, the values aren't directly comparable across cities. My goal, right, is to understand kind of broad trends and how these things are changing over time. And what I find initially is a lot of variation in the relationship between racial and economic and environmental marginalization, in particular across cases. So, right, this is kind of focusing on the far left of each of these charts. I find that the effect of this non-white variable is positive in some cases and it's negative in other cases. And in Minneapolis, it's insignificant. So there's a lot of kind of cross-case variation in that relationship between racial and environmental marginalization. There's a lot more consistency in how white nativity and in how labor shape environmental risk in this early period. Right, white immigrants and people in laboring professions are much more likely than other groups to live in close proximity to this heavily polluting industry, in 4 and 5 out of cases, respectively. Right, but still, right at the beginning of the study period, the relationship between race and environment, those two components aren't really yet tied together in space. But this changes significantly over time. So this next figure displays the second difference values comparing the effects of these key variables at the end of the study period in 1930 with that 1880 wave that I just talked about. So this is a way of analyzing change over time. And what I find here is this really significant shift in the social stratification of environmental risk over this 50-year period. So again, focusing on the left-hand side of each of these charts, this analysis reveals a positive and significant slope for the effect of that non-white variable across every case that I analyzed. This means that over that 1880 to 1930 period, the effect of racial marginalization on environmental exposure was increasing across the board, increasing strongly in every sector. And that's regardless of how racial environmental inequality was organized at the beginning of the study period. And this is especially significant because it's really the only significant change over time that's consistent across these 6 cases. The cases exhibit a ton of variability in how country of origin, occupation, and these other control variables that I'm not displaying shaped that question of environmental exposure. It ends up being race, and really only race, that emerges as this consistent trajectory in the decades leading up to the 1930s. These findings are generally confirmed when this has all been at the district level. And the findings are generally confirmed when I zoom into the street level as well. I ran these street level models for a subsample of 4 urban areas. And that's because doing that street level analysis required a huge amount of manual coding, harmonizing street name changes and variations in how census enumerators recorded street addresses. And basically the Baltimore and Cleveland cases had some pretty big shifts in street geography that made it really kind of especially challenging to compare over time in those 2 cases. So I'm focusing on the 4 cases that I have up on the screen. And I find a generally similarly uniform increase in racial environmental inequality in 3 out of these 4 cases when analyzed at the street level. And Minneapolis is kind of the one exception. That said, in the Minneapolis case, that non-white variable does gain statistical significance between 1880 and 1930. It just doesn't change in magnitude, which is why the second difference statistic doesn't reflect that change over time. But by the end of the study period, Minneapolis, I find this significant pattern of racial inequality and environmental exposure, whereas in 1880 that wasn't the case. So again, and also like at the district level, these other predictors are really case specific rather than showing this kind of broad cross case trend that we find focused on race in particular. So in summary here, what I'm finding is a broad shift in how patterns of environmental inequality were structured during the initial formation of the segregated and unequal neighborhood. Racial and environmental marginalization are increasingly bound together in space over time. And that escalation in racial environmental inequality emerges as a generalized process across cases, in contrast with the case specificity of other sociospatial processes. And this is all happening as the neighborhood is first solidifying as the primary unit of segregation and inequality. So with that in mind, I'm making kind of 3 broad contributions. Empirically, I'm bringing in these data from 19th century cities into conversation with a field that has a strong late 20th century bias, and finding that racial environmental inequality is a much earlier formation than other empirical studies have been able to show. I'm doing this by taking advantage of this methodological contribution in how we bring environmental data into historical analysis. And this enables a theoretical intervention as well. So I'm finding evidence that environmental inequality is likely deeply embedded in unequal spatial structures that emerged in the early 20th century that have largely persisted since then. Urban environments, thus emerge as this key part of the racialization of urban space in US cities. And if that's the case, then the segregated and unequal neighborhood is likely likely formed through a much more deeply environmental process than we often recognize. This suggests, I think, that racial environmental inequality is likely a fundamental and generalized process that shapes the structure of the modern city, going back to this initial formation of neighborhood racial segregation 100 years ago. So this has all been my talk has really been in the historical realm, but it also matters for how we ensure the good life, right, for city dwellers into the future. So as extreme events that are related to climate change start to increase, these kind of old environmental sites might cause new kinds of environmental harms as extreme events, right, mobilize industrial contaminants that were forgotten or sequestered. Tom Marlowe's work has been a really important part of demonstrating this temporal dynamic. In this way, this convergence of these historical and present and future forces might exacerbate existing patterns of environmental inequality and produce new forms of environmental and climate injustice moving forward. So I'll end here. Thanks so much for coming, and I'm excited for your questions. I should acknowledge a couple people, particularly Scott Frickle and Margo Jackson, Jennifer Candidaten Brown, as well as a number of other collaborators and colleagues and reviewers who have all provided really important feedback on different versions of this work over time. So thanks so much to CURA for hosting this event, and looking forward to any questions that you might have.
Yes, thank you, Jonathan, for that really interesting presentation. I alerted everyone in the chat. Please remember to go ahead and add questions using the Q&A functionality in Zoom, and as we see those come in, we'll address them. But I think I'll get us kicked off, maybe just building on kind of the last slide there, talking about the the legacies of this infrastructure and its potential impact moving into the future. What kinds of, what would you hope if there were city planners or policymakers that would encounter your research? What do you kind of think would be the hoped for takeaways that might influence the practices moving forward to try to mitigate some of these harms?
Yeah, thanks for that question. I think there's sort of two sides to it. There's the kind of long-term question of how we kind of repair these embedded structures of inequality in cities. And on that side of the equation, I think that this kind of work, I hope one takeaway I'd hope that people would have is that kind of repairing that kind of inequality really requires a much deeper set of ways of dealing with the distributive politics in cities and urban land use over time than cities are often prepared to engage in. And kind of the other side of the equation is kind of the long-term legacy of this kind of site is the piece I didn't really get into in detail, which is kind of why is this kind of historical data hard to deal with, is that it has to do with environmental governance and broadly speaking, kind of high level remediation policy tends to focus on kind of really visible large scale sources of environmental pollution, and the sort of smaller scale pieces can get lost in the mix. And an interesting thing about the coal gas case is that it kind of crosses that scalar boundary. We have this, these large scale sites that the state has been focused on, Superfund level sites, and also much smaller scale pieces of infrastructure that were scattered across urban neighborhoods, and that largely not dealt with. And so I think that sort of scale question is a big part of what this might bring to that kind of remediation process.
Thank you. And we've got some really great questions coming in, so I'll take the first one here. Can you speak again about how you got street segment level demographic data? I think you said the address data doesn't exist, so I'm wondering how you assigned people to street segments.
Yeah, that's an important thing to clarify. We don't have the ability, so the thing that doesn't exist is the ability to locate addresses in space. Census microdata give us basically strings of street addresses, so we know that somebody lived at 47 101st Street in 1930, but we don't know where 47 or 101st Street is. That said, we do know people's enumeration district locations, so that person on at that particular street address, we know that they lived in enumeration district 65, for instance. So it's possible to then combine that enumeration district number with the name of the street that somebody lived on in order to place people in somewhere along this kind of linear street segment, and also to know where that street segment fell in the city, kind of broadly speaking. And then that makes it possible to link individuals at this kind of smaller scale in terms of where they live in relation to this kind of infrastructure. And that process involving coding the infrastructure data for which street names kind of intersect those polygons. So it's a way of getting down to a more detailed level of the enumeration district, of drawing on that aspatial address data as well.
We have another question here. Hello, I'm currently working with Sanborn Fire Insurance maps and smelter sites. If I'm comparing 1930s to present time, what could I use for the present time to compare a difference in income level, race, ethnicity, and education from the 1930s? Do you have any thoughts on that?
That's a super interesting question. Interesting question. So on the kind of the socio-demographic side of things, I would recommend taking these sort of enumeration district aggregates from the 1930s and apportioning them to contemporary census tracts. 1930 socio-demographic data are at this smaller scale, so you can get a pretty accurate. It's pretty accurate to then reassign those districts to a maybe like 2010 or 2020 equivalent census tract geography. If you're looking to compare the site data side of the equation, I'd be less familiar with that. But something like a smelter site is likely to be tracked by the state pretty in some pretty good detail. So that's
I saw on one, Jonathan, I saw on one of your slides you referenced the National Urban Historical GIS project, and that kind of ties in with the NHGIS. Are you thinking kind of those types of resources potentially?
Yeah, for the socio-demographic data, I would Google search spatial structures of the social sciences and find their spatial census data resources, and that you can deal with. I've been dealing with it as a individual level data, but you can also aggregate those individuals to those enumeration districts, and then aggregate those enumeration districts to something that's equivalent to contemporary boundaries. But also, anyone's welcome to shoot me an email, and I'd be excited to talk about it in more detail.
I'm gonna skip a couple here and come back because we have one that just came in that I think is like very closely related to what you were just talking about. Just a methodology question. How do enumeration districts translate to current census tracts? Is it a straightforward mapping, or is there a larger hurdle to clear if we want to move into a more modern environmental analysis?
Yeah, you can use if you're into R, you can use an aerial apportionment. I believe the package is called. The boundaries won't line up perfectly, but it'll be because of that kind of scale difference. I don't think you run into too many problems. Enumeration districts were generally meant to be canvassed by census enumerators who are working on foot, and so the boundaries often follow infrastructural or environmental boundaries like rivers or rail lines. And I'm less familiar with how contemporary census tracts are mapped, but I think those environmental divisions are likely to be as well. So especially that scalar difference means that I think translating between historic data and more contemporary data is pretty defensible.
This is a really interesting question. Is the issue of environmental racial inequality a uniquely American problem, or are there comparable countries where this issue exists?
That is a great question. I've really been deep in the weeds of US cities on this one. And so I don't have a great answer for you. I know there was a pretty well publicized work a number of years ago. I think it was coming out, might have been in the New York Times even, relating socioeconomic geographies in European cities to wind direction, which carried kind of air pollution in particular patterns historically, and that kind of led to different settlement patterns over time. And of course, like U.S. racial formations are unique in this way, but the kind of role of environment shaping stratification in cities more broadly is of course not a uniquely American problem.
Thank you. We have a comment here. Fascinating work. It gets at the simple question of what comes first, the people or the hazard. It's obviously a complex and iterative process. Do you have any qualitative evidence for how the racism that was behind the development of neighborhood level segregation explicitly took environmental inequality of the type you are measuring into account?
Yeah, right. There's the classic kind of which came first question. Yeah, so kind of some of the post 1930 research that's been coming out relatively recently is a great, I think, window into that. So Raul Livanos's work, I know at the University of Oregon, he's spent time with the kind of analyzing the kind of cultural, institutional, and ideological formations of federal housing administration employees and administrators who were involved in the redlining process in the 1930s, and finds that that like ideological link between racial and environmental marginalization was a big part of how those kind of state officials were making their decisions and kind of guiding these institutional policies. And that's sort of that's right after the period that I'm studying. So at least by that point, the sort of ideological equation between race and environment and space in particular is there's some good evidence that shows how that comes to be, or how that was at least perpetuated starting in the 1930s. And in terms of this kind of pre-1930 period, I'm starting to define the socio-spatial process, but the institutional processes are still open for analysis.
Great. We have another comment here. Fascinating talk. I happen to study how Gasworks Park's decommissioning and development as a park was accompanied by a downzoning of the adjacent neighborhood. Did you ever find discrepancies between Sanborn maps and the census data? And did you build that into your model or have to pick it apart, quote unquote, by hand?
Interesting. I would love to learn more about the park construction process. It's a wonderful park to visit. It's really interesting how it changed over time. Yeah, so one interesting piece that might get at your question is even starting in the 1800s, something that comes out in the Sanborn maps is that kind of industrial land use was interspersed a lot more directly with residential land uses. And this is sort of before that sort of zoning. Municipalities started to separate those zoning processes in kind of a more sustained way. But you do start to see this separation of uses that, and I didn't have time to talk about it in a lot of detail, but I've been working on a pilot analysis of how gas infrastructure predicts subsequent industrial land uses, and at least in the Providence case, the location of gasworks is a good predictor of manufacturing industrial land use. in the mid 20th century. So there's kind of a processional, there's a process where these kinds of land uses are kind of maintained over time, and there's this increasing separation between industrial and residential land use. So that's sort of a more anecdotal answer to your question, but the sort of having to deal with the maps in a pretty direct way throughout the research process was different than if I just been handed this model. So, definitely shaped how I was thinking about it over time.
That sounds like a really interesting kind of pilot project that you're working on, and I'm gonna ask sort of a two-part, maybe follow-up question. The first one is, since you've carried out this particular project, are there other research questions or research projects that you've already completed that kind of followed up on it? And then secondarily to that, sort of what do you think might come next? Are there other research questions that really kind of got their origin through this project that you're hoping to address in the future?
Yeah, that's of course there's 1,000 ideas and we can only do one or two of them at a time. But this so the project I presented today is really talking about that sort of racial and environmental marginalization question. And there's a reason for that. I'm not directly measuring segregation, even though that's the process that's kind of underlying the research question that I'm interested in. And so sort of one piece is formalizing that relationship between between industrial land uses and segregate and small scale segregation measures. And there's a couple ways of measuring. Most segregation is kind of measured as a citywide phenomenon. There's full ways of getting down to some smaller spatial scales. So kind of integrating segregation indices at a smaller spatial level is one direction that I'm excited about. There's also this, there's been a ton of work on redlining coming out after folks at the University of Richmond digitized the redlining maps a number of years ago. And, at least theoretically, the processes that I've been looking at leading up to the 1930s, I'm interested in whether those, kind of the role of those redlining policies in kind of fixing those neighborhood differences in place. And if there's a way to formally link this sort of pre-1930 process with that post-1930 institutionalization of racial and spatial inequality. Those are the kind of two directions that I've been exploring, and of many different thoughts.
Yeah, that sounds really interesting. Just want to mention we have about a few more minutes, maybe for one or two more questions. So if folks have additional questions, please feel free to put them in the Q&A. One of the things that kind of struck me about the methods that you described in your talk, and then the topic overall, and some of the historical resources that you were talking about, is there's sort of this like juxtaposition of fairly sophisticated modern machine learning techniques and geospatial analysis with archival resources and historical maps. On that side, the archival resources, are there any kinds of experiences or maybe historical resources beyond the maps that you engaged with that you felt were really impactful for the context for this project?
Yeah, there are two pieces to that. Because it's in the environmental realm, there's kind of the whole environmental science side of people who have dealt with, well, Sanborn maps in particular, which are a huge part of environmental remediation processes, and then the industry as well. There's kind of at the beginning of the process, paid a lot of money for a 1,000-page book about remediating manufactured gas works, and understanding the logics of that industry was a big part of kind of understanding that it might be an interesting case to select, and also understanding where it might be found and how I might go about doing that. And then on the kind of more archival side, institutional records have been really important in some small but key ways. Gas companies were big, important, socially visible institutions, and they really enjoyed writing about themselves. And there's these wonderful gas industry journals that have these narrative descriptions of the development of particular gas industries or particular companies in particular places. And So there's some wonderful kind of narrative descriptions of how the gas industry in Oakland developed. And that was, those sort of archival pieces were important for locating sites that predated the sort of earliest Sanborn maps that I was able to access. And sometimes those sites would be visible as kind of decommissioned or converted pieces of infrastructure, but sometimes it might kind of go back to more narrative and kind of archival sources as well.
Thank you. There's another comment that's just come in saying there's a great study on Sao Paulo by James Holston called Insurgent Citizenship, Disjunctions of Democracy and Modernity in Brazil. For those interested in cities outside of the US, environment is not the explicit focus, but it's there and plays an important role in how race and class and access to resources tied into the city's development and who got/gets to live where. So a nice international example there. Thank you for sharing that.
That's, yes. Oh, I wrote it down and I'll have to look it up. Thank you very much for passing that along.
Well, I think with that, I just want to say, please join me in thanking Jonathan. A great presentation, really interesting topic. Excited to see where you take this research next.
Thanks everyone for having me. I'm excited for the rest of the seminars this summer. So,
Yep, yeah, and I'll just mention that our next event in this series, Maps from the Past, will be on Friday, July 12th at noon, and the title is Using Historic Maps in Studies of Structural Racism and Population Health, and our speaker will be Helen Meyer. So we're really excited about that one. Take a look at the CURA event calendar if you would like to register, and we will hope to see you at that one. Otherwise, thanks for joining today, everybody, and have a great weekend.